So here is another question where we have to maximize a function, in this case f of x. So the question is maximize f of x, that is to find the maximum value of f of x if x is real. So this is the condition which we have to satisfy, that is x cannot take any complex values. So it turns out that this condition is actually essential for solving this problem. Without this condition we won't have the enough information, we won't be able to solve the question. So now I'm just gonna follow a precise method which will solve the question, and once we reach a particular step in the method I will tell you why did I particularly choose that method. Till that time just bear with me. So f of x is 3x squared plus 9x plus 17 divided by 3x squared plus 9x plus 7. The method is to actually equate this to another number or a variable, not a number. I chose the symbol lambda. You can choose any other variable you want, for example y, h, or any other Greek alphabet, or the or a letter out of the alphabet. You know what I mean. But anyways, I have chosen lambda because it looks good. And so now I'm going to rearrange this equation. I'm going to bring this thing to that side with lambda. So this will become 3 lambda x square plus 9 lambda x plus 7 lambda, and this will be equal to this term right here, which is 3x square plus 9x plus 17. Now I'm going to bring this thing here so that I get 0 on one side. So 3x square goes this way, so it becomes 3 lambda minus 3 x square. 9x goes here, becomes negative. I get 9 lambda minus 9 x, and similarly I do the same thing with 17. So therefore I am left with 0 at the other end. So now comes that step which I was telling you about. I have this quadratic equation in x where the coefficients are in terms of lambda. A is this, B is this, and C is 7 lambda minus 17. B is 9 lambda minus 9. A is 3 lambda minus 3. But we have to maximize lambda, and so far the information here is pretty useless. We don't know what to do with it. But remember I had said that x is real, and the fact that x will satisfy this equation, of course we just rearranged it from the original function, so x will satisfy this equation. So b square minus 4ac has to be greater than 0. If you've studied quadratic equations, you should know that a quadratic equation in x should have real solutions only if b square minus 4ac is greater than 0 or greater than equal to 0, but we won't be writing equal to here, and I will tell you the reason later. I'm just going to solve this inequality right here. So why am I actually solving this inequality? The answer is to solve the question. Why? Because if I plug in values for b, a, and c here, I'll get a quadratic inequality in lambda. B is in lambda, expression lambda, a is expression lambda, c is expression lambda. So I'll get a quadratic inequality expression lambda, and the fact that I have to solve that quadratic inequality, I'll actually get a range of values for lambda which are allowed so that x is real, which a range of values, yeah, which allows x to be real, or should I say. So then once we have that range, we will just have to choose the maximum value of lambda, and that will be our answer, since we just have to maximize lambda. Speaking too much lambda. So now I'm just gonna erase this stuff to make sure that you've understood the method. My god. Just 1 second. Erase it. There we go. So now I have this equation. I'm just gonna rewrite it in a simpler way. I'm gonna take out this thing. I'm gonna take out the 9 out of here. Excuse me. So b square minus 4ac has to be greater than 0. So b is this 9 into lambda minus 1. So this squared minus 4ac. A is 3 times lambda minus 1. C is 7 lambda minus 17. And this should be greater than 0. So this would be 9 squared times lambda minus 1 squared. This means 81 times lambda minus 1 squared minus 12 times 7 lambda times 17 times lambda minus 1. This is greater than 0. Just gonna erase the stuff. So now I can take lambda minus 1 common to make things simpler for me. So I just take lambda minus 1 outside, get 81 times lambda minus 1, and I get minus 12 times 7 lambda minus 17, and I put greater than equal to 0. I hope I've done it correctly. Yes, I have. So now I get 81 lambda minus 81 minus 12 times 7 is 84, I think. Yeah, it's 84, and 17 times 12 should be 170 plus 34 should be 204. So this should be 204. Yeah. So this so far so good. Now I can simplify it further. This becomes minus 3 lambda. 204 minus 81 is 123. Yeah, I'm pretty sure that's correct. Okay, and this is greater than 0. So we finally got our quadratic inequality. Now we have to solve it. Let me highlight it in magenta over here. Let me erase the rest of the screen. There we go. So now we have this equation to solve, this inequality to solve. So, oops. So I'll just continue to solve it in magenta now because I like it. And this is minus 3 lambda minus plus 123. What is this happening? Greater than 0. Yeah. So now I'll make a sign diagram to solve this inequality. So one solution is 1 and the other is minus 23 divided by minus 3, which is 41. And this thing has to be positive. So let me take a test value 0 and let me plug it in into this equation for lambda. 0 minus 1 is minus 1, and this becomes 123, and this is negative. So this will be positive and this will be negative. This is, we just alternate it because it has odd powers. If you had an even power, you wouldn't have alternated it. There will be a different method for it. But yeah, in general, this is how you solve a quadratic inequality. This is like a shortcut method for solving it. But if you want to, really see how you solve it, you can just create cases for it and to see the factors. So in this case, one case would be both of them are positive and the other case would be both of them are negative. and then you plot each of them on a number line, and whatever intersects on the number line will be your final. And in this case, a sign diagram just simplifies that for us. So yeah, in order for this to be negative, lambda has to be greater than 1 and lambda has to be less than 41. But now the inequality should have been greater than equal to 0, because x will also take real values when the discriminant is 0. It will just take the same values. The only difference is this. So in fact lambda can be equal to 1 as well, and lambda can be less than or equal to 41 as well. I did not put the equal to sign before because I don't know, you don't generally solve it with the equal to value. I've never seen an inequality like that. If you have, just put it in the comments or stuff. And so we have this range, lambda is greater than equal to 1 and lambda is less than equal to 41. So the maximum value of lambda will be 41, and that is indeed our answer. So the maximum value of f of x, which was this 3x square plus 9x plus 17 upon 3x square plus 9x plus 7, its maximum value could actually be found by this simple method, by equating it into lambda and using the piece of information which we had about x having real values. And it turns out that f of x has a maximum value of max value of 41. And yay, we solved it. Let me highlight my answer because I am really proud of what I've done. Boom.